Okay, here we're going to be going through number 6. How many moles of selenium oxide are needed to produce 183 grams of oxygen? So the first thing we notice is that this is an unbalanced chemical equation, so we've got to balance this thing first. At this point, I'm not going to draw the RP table because we can do this one pretty quickly just with our head. So notice that we have an O2 on the right-hand side. Let's put a 2 over here and see if that fixes that. We are okay in the O's, but we got to balance out the selenium, so there we go. Now we are correct. Now we are balanced, and now we're good to go. So the question is, how many moles of this thing, right, do we need to produce a certain number of grams of here? So we're interested in these two, the relationship between those two. The first, again, notice that we have grams here. In order to do the relationship between these two things, we need the number of moles, right? We got to do a mole ratio. So our first job is to convert 183 grams of O2 into moles of O2, and then we can start using our molar ratio to figure out how many moles of selenium oxide we need. So first steps first. 183 grams of O2, well, how many moles is that? Well, the molar mass of oxygen is 16 per mole, and we got 2 of them. So that's going to be 32 grams of O2 is in 1 mole of O2. So when you crank this out with your calculator, 183 divided by 32, and I'm going to round here, I got 5.72. So 5.72 moles of O2. That's what we need, right? So 183 grams of O2 is really just 5.72 moles of O2. Now we can start doing the molar ratio to figure out how many moles of selenium oxide we need. So the molar ratio is going to be, it's 2 moles of selenium oxide will get us 1 mole of O2, and we get that from these coefficients right here. Right, there's an invisible 1 in there. So that's going to equal, we don't know how many moles of selenium oxide, but we know that we need to produce 5.72 moles of O2. So now we can just do some cross multiplication. We can say 1 times x is equal to 2 times 5.72. So 5.72 times 2, we get 11.44 moles of selenium oxide are needed. Okay, and that is how we do this one. Again, we got to think of it as sort of a step-by-step process. We have to go grams of O2 to moles of O2, and then moles of O2 to moles of selenium oxide, right? Let's do another one here. Let's do number 3. What mass in grams of O2 is produced when 57 grams of Na2O2 react? So again, let's highlight the idea that we are given grams of both, or we're interested in grams of both, but in order to do the molar mass, we got to convert those into moles, right? Because it's a molar ratio. It's not like a gram ratio. So first things first is let's figure out how many moles of this 57 grams is. So 57.0 grams of Na2O2, and now we got to do the molar mass. So we add up the pieces of sodium. We got 2 sodiums. Each one is 22.99. And then each oxygen is 16, so 2 of them is 32. And we get 77.98 grams for 1 mole of Na2O2. Okay, so how many moles of Na2O2 are we talking about here? So it's going to be 57 divided by 77.98. And we get 0.731 moles of Na2O2. Okay. So now we're okay. We got moles of Na2O2. We're trying to figure out what mass of grams of O2. So the first thing we got to do is figure out how many moles of O2 will be produced, and then we just convert that to grams at the end. So again, think this is a sort of a step-by-step. We went from grams of Na2O2 to moles of Na2O2. Next thing we're going to do right now is go from moles of Na2O2 to moles of O2, and then we're just going to convert that back down to grams. Okay. So let's do a molar ratio. The molar ratio, it looks like it's going to be a 2 to 1. So it's going to be 2 mole Na2O2 will produce 1 mole of O2. And we have 0.371 moles of Na2O2. And how many moles of O2 will that produce? Okay, so 2x equals 0.731 times 1. Remember, I'm just cross multiplying here. So it looks like 0.731 divided by 2 is 0.3655 moles of O2. Okay, we're almost done, right? So again, we went from grams to moles of Na2O2. Then we went from moles of that to moles of O2, and now we just got to bring it back down to grams. So here we go. 0.3655 moles of O2, and let's do the molar mass for O2. That's easy, right? Because it's 2 times 16. So that's 32. So we got 0.3655 moles of O2, and it's 32 grams for each mole. So 0.3655 times 32, and we get 11.70. I'm rounding, but it's 11.70 grams of O2. And that is how we do it.